Hello everyone, welcome back to autonomous driving tutorials. In previous one we were talking about building a model to blend GPS and visual navigation or computer vision navigation. And I've for option 1 I've noted a few points last time. So today we gonna drill down conceptually how we do this. And for that I created a new folder in my GitHub repository. So there is a folder called GPS with Vision, and I've got a couple of notebooks here. One of them is preps, which is like exploring and preparing, and the code at the bottom of the preps is what's running now and showing you the car going around. My objective here was to test these sort of telemetry numbers that you see in here that I will explain later, because I just wanted to check the quality, what they will look like in reality as the car drives around before I start generating this imagery with those numbers and training the model, only to find out that the model is crap. Anyway, and then step 1 is the actual code that generates the images. And hopefully you'll get this _img folder when you replicate my repository on your machine, but it needs to exist before you run step 1. Okay, now we're going into the explanation. Just a refresher on predictive models. I know it just scares many of you, and especially people who are not involved in predictive models. Predictive models are generally something that you train from examples. Like you've got a bunch of examples on the left and they represent something. It could be, completely different things. Like it could be predicting, diagnosing certain diseases from blood test results or something like that. So for example, blood tests, there will be a number here, outcome negative. So the outputs or outcomes are also called labels. And that's why for traditional non-simulator autonomous driving, it's actually quite labor-intensive part, because they have plenty of imagery and video recorded in real cars, but they need to be labeled. Like for example, this image is like the car needs to go straight, or that image is a collision, or that image is this kind of danger. So the beauty of the simulator, we exploiting the simulator to give us these accurate labels, because we generate this data on the spot, and that's the advantage why we do this in a simulator. The other important factor is like our examples, our inputs and outputs should be aligned. So we shouldn't be confusing different examples with different outputs in the process of training this model. Hopefully it makes sense. Like I'm not going too deep at this point. I'm just trying to convince newcomers to this space that it's actually the concept is actually straightforward, and then as you get into it, obviously you get over complexities as you go. Okay, in our specific case, what we're trying to do is we've got our inputs, and significant part of the inputs is these images, and we've got our output, which is a steering angle that we need to predict. We also need to incorporate our GPS direction. So it's like blending GPS direction or spatial navigation with image data is the very thing that sort of blends them together. Okay, so we need to feed both into the model. The output in those cases is exactly the same. We only want to see what the steering angle should be based on this. So we're training the model from examples. Each example will represent one of these images, only one GPS direction, and we'll talk about it later. And on the output, it will have a specific steering angle. Like in this case, it will probably, okay, it looks like the car needs to go straight. Then we've got direction from GPS, and then it probably means that the predicted output or label in this case that will train the model from should be 0 as well, or the car driving straight. The training images, as I mentioned before, it's semantically segmented images. And what that means, all these colors are reserved for certain objects on the road. Like you see, cars have specific color, the lane markings have specific color, and they're always consistent, and you can rely on it. And that's another advantage that we're using from the simulator rather than training this in the on the real world imagery. Okay. The other thing, as far as images are concerned, we obviously need to pair them with the other two elements. We need to give it GPS input, and we also, or navigational input, and we also need steering output. So we need to have 0 for probably driving straight, and we're going to talk about GPS input next. Okay, GPS input. The more I thought about this, it may not be quite consistent to what I said before, because last time I was talking about possibly having it as an angle to a waypoint which is quite far ahead from us to sort of represent general direction where we need to go. But the more I thought about it, for simplicity, it should be, you know, picture a passenger sitting next to you and saying, or directing you, like, next we're going right, and next we're going straight, and next we're going right. It's funny how I meant to have left in one of these here, but I've only got rights. Anyway, what it allows us to do is to say, we're gonna have -1 representing we go in next left, or 0 will represent we going straight or just following the contours of the road. Like, for example, if the road is bending and going sort of around something, but it's not turning, it's 0. And then +1 to represent going right. So that makes sense. And I've also wanted to show you the code that I've got for that additional function that I created in this version of the tutorial. So the step 1 in that folder that I showed you before is a very similar copy to tutorial for final code, but it's just simplified a little bit. And it's the main thing that we're trying to incorporate here. We're cutting the images into files. We label them certain way to represent our GPS direction and labels. But the main thing, the key additional thing is just here, how we're trying to pick 0, +1, or -1. And as far as labels are concerned, we're just using exactly tutorial 4 approach, where we know the angle is of what the car is doing is quite accurate, because as you can see, the car stays in the lane, within the lane quite well. So we're using that very angle that we're getting as part of tutorial 4 that we send into the car steering wheel. And that's what we have it as our accurate label. Like, based on the car seeing this, it needs to produce this steering angle in this navigational direction. Okay. And then as far as putting those things into the file name, so as I create every single image, this timestamp goes from the time module within Python, and it's just a number, and I'm like, I don't really care what it represents, but it makes every sort of file unique, and there's no way for them to be the same for images generated at different times. Then I put the result of that function that I showed you before, the direction, like in this case, 1 is right, of course, and 0 is straight, and -1 is left. And then the label that should be predicted from this. And again, just to recap, all we're doing here as far as training the model is to say, in this example, when the car sees this, and by this I mean what the image represents, what you see in the image, given that we need to go to the right, which is what this one gives us, the car needs to predict 15 degrees. So it means in that case, with that direction, we need to turn steering wheel 15 degrees to the right. Okay. And then final words, sometimes when images are generated, you get absolutely black. I have no idea. It's probably one of Carla quirks that I can't figure out. But the way to get rid of them, when everything finished running, I think it goes for 2,000 images in one go. If you want, you can run it again and generate a few more. I think there is a restriction, like each next image should be at least 1 meter away from previous, so you don't get a lot of very similar copies. But if you get black only images, they're only small 3 kilobytes in size, so you can just sort all the directory in the order of the size and then get rid of all the black ones. That will be, you'll see them, they're very small. The other restriction that you may implement here is, as you start generating images, just check a few of them that they're eligible, and they need to look as let me go yes, they need to look like this. And if you see something that is completely illegible, it means you need to do this in version 13, the previous version of Carla. And when you switch to Carla 13, you also need the different Python environment that uses version 13 of Carla Python. Okay, with that, hopefully it wasn't too tedious. I'll thank you for your time. Please don't forget to like and subscribe if you enjoyed this video. And I will see you in the next one, where we will be building the model from these images. Thank you. I'll see you later.